Modeling with cubic functions. This is part 2, example 3. Modeling real life. The data shows the numbers Y of active bald eagle nest in Florida 2 years after 2000. Find a model for the data. Use the model to estimate the number of active bald eagle nests in 2018. All right, so it says active bald eagle nest in Florida. T is the number of years after 2000. So if we come down here and look, T0 would be year 2000. And then 2 years after that would be 2002, 2004, 2006, and so on. All right, so it says find a model and then use the model to estimate the number of bald eagles in 2018. So the first thing we want to do is see if this is a linear, quadratic, or cubic model. So you could look at the differences here. These numbers are a little larger, so let's just look at a scatter plot in our calculator instead. So what we need to do, first let's turn on our stat plot, because when we go to graph it, we want it to show up as dots on the graph. So let's turn on our plot, and then on, and then this says type. So, and you can make different types of graph, but we want the dot plot. So we want just a scatter plot. And we want it to pull from list 1 and list 2. And it's going to just show little squares is what it's going to show up. So let's hit enter there. And then we can do second quit. And now we need to enter these numbers in our table. So go to stat, edit is number 1. And I'm going to pause the video just for a second, and I'm going to enter these numbers. Make sure you put T, all your T values from both rows here. T 0 through 20 will go in L1, and then your Y values, again, both rows, will go in L2. So take just a moment, enter that in your calculator, and then we'll continue after that. All right, hopefully you have taken a moment to enter things in your calculator here. And then once you have these in, make sure they're correct, and then hit second quit, and this will save your list in your table again. Now, if you want to change your window, okay, I've already changed my window here, but these go from 0 to 20. If you are a normal 10 by 10 window, nothing's going to show up unless you change this to make sure that the numbers are included on the graph. So T is your horizontal axis, so that's going to be your X. So your minimum has to be negative, so we can make it -1 or 2. And the maximum needs to go at least above 20. So I'm putting 22 here. I'm going to leave that by a scale of 1 because that's just telling you like how many little dashes you see up or across the X axis. And then my minimum Y value, again, there's no negative, so just a small negative number. And then the maximum number, you can see my Y's go from, well, here's 1511, 1568, 1500. So it looks like 1568 is the largest Y value, so I put 1600 in here, which is slightly above that. And then we don't need 1600 little dashes up and down the Y-axis, so I'm changing this to a scale of 100. So it'll be 100, 200, etc. So when we hit graph, that's going to show up now with our dot plot. And these numbers again come from this table that we entered in our stat edit. So this is our dot plot. So it is kind of curved like a cubic function. So let's see if we can write a cubic function for that. All right, so I'm going to turn on my diagnostics, which tells me how strong my regression is. So if you go to second catalog, scroll all the way down to where it says diagnostics on. Probably a faster way to get down here, but anyways, I just scroll down until the little arrow has to be next to diagnostics on. I hit enter twice, and that's going to turn on my diagnostics. Now again, what's that going to do? When I write a cubic model, it's going to tell me how strong the regression is. So let's go ahead and try that. So I'm going to go to Stat. This time instead of Edit, remember I've already put my points in. This time I'm going to Calculate. And I want a cubic regression, so number 6. And so this gives us our cubic function in standard form. Remember, your highest exponent to your lowest, so this is in standard form. We have looked at different forms today using the intercepts. We looked at intercept form, but this is in standard form. And it gives us our A, B, C, and D. And then it gives us our R squared equals 0.976, so about 0.98, which means it has a really strong regression. So that means it does fit a cubic model. So the first thing it says is to find a model. So let's go ahead and write this down. And you can round. Usually we round either to the 10th or the 100th place. Kind of just depends on the numbers. All right, so that says find a model. So we've done that. This is our model. And then it says use the model to estimate the number of active bald eagle nests in 2018. All right, so again, T is the number of years after 2000. So 18 would be 2018. All right, so we're going to go back to our calculator. What we want to do, let's first graph this. So if I go to y equals, all right, and I go to vars, and I come down to 5, statistics, and I go over to equation, what this does, so again, that's vars, I can't remember, stat, and then equation, and that copies the equation over into my y equals, which means when I hit graph, it's going to show the linear model with the scatter plot. So I kind of like to look at that because you can visually see. Remember the R squared was 0.98, means this is a very good model for the data. And you can see that that is true. This is a very good model for the data. So again, that was vars number 5, statistics, and then equation. And that copies that over into the y equals button. All right, so we don't need to do that again, but there is our graph. I'm going to pause this and make a copy of the graph here. All right, so I just took a screenshot of that. It won't let me continue the video at the same time, so I had to pause the video, but just wanted to make a screenshot of the graph so we have that. Now it says use the model to estimate the number of active bald eagle nests in 2018. So the easiest way to do that is we know that 2018 is going to be T of 18. So your X value is 18. So we have our table. If we go second table, we can scroll down. And this is how to do it using the calculator. And you can see at 18, it's 1,562. So we can say there's about 1,562 bald eagles in the year 2018. Now, another way to do that, if you didn't want to look at the table, you could remember to put 18 in for T. So you could type this equation into your calculator. If you just go to right here, you could type this in and then 18 cubed plus this number, 18 squared, minus this number times 18 and then plus this number here. So if you type all of that in with substituting 18 in for T, you should get pretty much the same thing. But I like, if I'm going to already have all this information in my calculator, I'm probably just going to use my calculator to also look at the table, and it gives me the 1562. All right, so it's the answer would be you can estimate the number of active bald eagle nests in 2018 was about 1,562. Do we think that's pretty accurate? I can conclude that that is pretty accurate based on my R-squared that said this was a very good model for this set of data. So that means this is a very good estimate for the number of bald eagles in 2018. All right, that's all for this lesson. If you have any questions, please let me know.